Hello, my name is Anushka, and today me, along with Kornpech and Nuttida, will be presenting our physics project about nuclear energy. This project will include what nuclear energy is, how it's produced, and what the purpose of nuclear energy is. So to begin with this presentation, we're going to talk about the abstract. The abstract of this presentation is what nuclear energy is. Nuclear energy is important because it initiates an amount of energy without emissions or pollutants. It's also helpful with the air quality by producing carbon-free electricity. As carbon-free electricity is produced, it helps to reduce the greenhouse gases, such as carbon dioxide and methane, and thus it lowers the impact of climate change. So in conclusion, nuclear energy is one of the best alternative way to produce electricity which generates less carbon and causes less air pollution. What is nuclear energy? The nuclear reactions either by nuclear fission or nuclear fusion which causes the breakdown of bonds which releases energy. This energy is called nuclear energy. Actually, the energy that holds the nucleus together is in the core of the atom, or the nucleus. The power that holds the nucleus together is called a strong force. The next part of this presentation is going to be introduced by Kornpech. She is going to talk about the two ways a nuclear energy is produced, which are fission and fusion.
Nuclear fission. Nuclear fission is a process in which the nucleus of an atom splits into two daughter nuclei. It occurs when a neuron hits the nucleus, causing it to split into small nuclei. By breaking the bonds, there is energy released in the form of heat or radiation. The heat released can be converted into electricity through nuclear reactors. Nuclear fission. So the atomic nucleus has protons and neutrons in it. So in the uranium nucleus, the fission separates the uranium nucleus into other elements, and the fission energy continues, and the chain repeats itself on and on. So I'm going to explain more into depth about nuclear fission. An example of nuclear fission is when uranium-235 got hit by a neutron, which causes it to split into two lighter nuclei, barium and krypton. The equation of the reaction is uranium-235 refers to the original atom before fission plus N, which the neutron that hits the uranium-235, so it breaks apart into smaller pieces. After the bonds break apart, it results in separating atoms, which is barium, krypton, and neutron. 210 mega electron volts as the energy released from fission. Nuclear fusion. Nuclear fusion is a process of joining small nuclei together to give a larger one. Nuclear fusion releases energy in the form of heat that is converted into usable electricity, similar to nuclear fission. An example of nuclear fusion is helium and lithium joining to boron. As the process occurs, there is energy released from fusion. So in this animation, it's what shows what happens in nuclear fusion.
Now we will be looking at graphs on fission and fusion. The x-axis in this graph represents the number of nucleon, and the y-axis represents the mega electron volts, or MeV, which is the binding energy per nucleon. So as fission decreases in size, the energy that is released increases because as the nucleon number decreases, the x-axis moves toward the right on the graph. In this case, a positive slope, meaning energy is released. Fusion builds up the nuclear number, the energy release increases because as the nuclear number increases, the x-axis moves toward the right on the graph, which is also a positive slope. Fusion releases more energy than fission since it has a steeper slope on the graph. How to calculate MeV release. To be able to determine the MeV release, the binding energy per nucleon must be given. Then multiply the MeV to the number of nucleon available. Then add up the amount of MeV and see the difference before the nuclear reaction and after the nuclear reaction. To determine the amount of energy released, calculate the change in energy, which is the energy after reaction subtracted by energy before reaction. We hope you learned something from our video and thank you for watching.